What's up, everybody? This is Coach Sharf, and welcome. Normally, I say welcome back to, but I'm going to say welcome to my Algebra 2 notes videos. This is the first note video I'm recording for in the 2022-2023 school year. We're right at the beginning of the notes. So welcome to everybody. I would say welcome to future years, but we're not going to be talking about this at the beginning of the year in future years because they're about to switch our standards starting next year, but that's neither here nor there. So anyway, welcome to my notes videos. I apologize for the big head, a little bit of glare from the window right here. Let's use my hand to block it out real quick. They got the new monitors at the edge of our desk. So normally my laptop would be a little further back, so my head wouldn't be quite this big, but I'm about to minimize my head when I do some examples anyway. So that'll kind of help y'all out. So what we're talking about today is simplifying radicals. Okay. We didn't really do notes on it. A few of the classes I didn't necessarily do it with all of them, just said what we're doing when we're simplifying radicals. So a radical is the radical sign is I'm trying to draw it in reverse so y'all can see it. Whoop, whoop, whoop. There we go. The root sign. The root sign is what we call a radical sign. Okay, that's what it's technically called. So even if it's a square root, cube root, fourth root, whatever. 99% of the time, if I refer to a radical, we'll see it here and we'll see it later on in one of the units in second semester. 99% of the time when we're referring to a radical, we're talking about a square root, which is what we're talking about in this situation. So when we're simplifying a radical, basically all we're doing is, this is really bad glare. I'm going to put my hand up here for a second. Basically all we're doing is we're taking a square root that is not a perfect square and breaking it down with a factor tree. That's the basics of it. All right, I'm trying to open the whiteboard. I don't know if it'll let me while I'm talking. There we go. Okay. Ooh, this is a little different now. I kind of like this. All right. So excuse me again. I'm sorry. So we're actually going to start with a perfect square to kind of help illustrate what we're doing. And then we'll look at, excuse me, I'm sorry. I had kind of a lingering tickle in my throat last week or so. We'll look at a non-perfect square to kind of illustrate it further. So the square root of 25. We know the square root of 25 is 5. And it's actually positive or negative 5. We've talked about that. So I can use a factor tree and also get to showing that same place. All right. So I'm doing a factor tree. I need two numbers that multiply to get 25. Of course, that would be 5 and 5. I can't break down either 5 any further. So this is as far as I can go with my factor tree. Okay. I'm going to leave this here and come back to it in a second. Square root of 12 is not a perfect square. 3 times 3 is 9. 4 times 4 is 16. So we know 12 is not a perfect square. So I just need to start with any two numbers that I multiply to get 12. You don't want to use 1 and 12. We didn't use 1 and 20. Excuse me. I'm sorry. We didn't use 1 and 25 previously. Maybe some of this is melted. Get some water. A little bit. We don't want to use 1 and 12, but 1 times whatever the number is, period, but anything else will work. For 12, we could do 2 times 6 or 3 times 4. Doesn't matter what you start with. When you do your factor tree all the way down, breaking down whatever needs to be broken down, you'll eventually end up in the same place. Okay. So I'm going to do 2 and 6, and then 2 and 3 is how we break down 6. So I've broken everything down. 12 to 2 and 6, 6 to 2 and 3, can't break down anything else. Before we kind of get to our final numbers and kind of piece everything back together. When you're doing your factor tree, if you write kind of bigger, kind of clearly, it's not crammed in, your handwriting's not really sloppy, I would recommend I'll use a different color just to kind of illustrate it. You don't have to. But I would recommend crossing out anything that you broke down. Makes it easier so you don't get confused when you're doing this last part we're about to do, and use a number that you don't need to and get the incorrect answer. So I cross those out. I'm left with 2, 2, and 3. My prime factors. We talked about this in class. Our factor trees, we're trying to get all the prime factors. Again, it's just literally prime numbers: 2s, 3s, 5s, 7s, 11s, 13s, 15s, 17s, 19s. Again, probably won't be any bigger than that. Okay. So I've got 2, 2, and 3. I got this pair of 2s right here. So any pairs you want to circle, they got to be 2 of the same number. So you want to put both of them in one circle. Any single digits, we will underline. Okay. For every pair, again, it's the analogy of this is a pair, they're a couple, they're dating. Friday nights, that couple is going to go out as one unit. So those 2 2s are represented by 1 2, a single unit. And they're going to go outside of the house. The radical sign, the square root sign is the house. So we put 1 2 outside of the house. The 3 is your single brother and sister. All their friends are doing other stuff tonight. They don't got the money to go to the movies or the club or whatever. Or they're just kind of introverted to begin with, and they're going to stay in the house playing Call of Duty or on Instagram, watching YouTube, whatever they're doing. So the single factor, the 3, stays inside the house, and that's it. So square root of 12 is simplified to 2 times the square root of 3. And we're still going to stick the plus minus out in front of that. So using our knowledge now, coming back here, I've got the pair of 5s. The 5 is going to go outside the house. There's no other single factors. So I actually don't have anything to put in here. So it's still just going to be plus or minus 5. All right, I'm going to do 1260. And again, looking at time, y'all might hear the bell ring. The bell gets me after I finish 1260. I'll just stop there. If y'all tell me in class you need more examples, I might record another short video and put it up. Excuse me. But hopefully, at least 1260 in particular, talking about a few things that should be comprehensive enough. All right. How do I get to a new? There we go. All right. How's that? I figured that'd be a way to do that. Excuse me. Gosh, can't get rid of this cough. All right, we're going to look at 1260. So I'm using 1260 for a few specific reasons. It's not solely just because it's a big number. This applies to anything. Again, if y'all look at that worksheet I give you, I think the biggest number on there is 175. So it's not solely that it's a big number, but the fact that it is a big number will allow me to show y'all a few things. The first thing is this. Again, when we're doing our factor tree, we need 2 numbers that multiply this to get 1260. That's a big number. Most people, if they thought of 2 factors to get this really quickly off the top of their head, it would probably, since it ends in a 0, I know it divides by 10, so it would probably be 126 times 10. If you thought of it very quickly off the top of your head. But again, our goal is to get this done kind of quick. You don't need to be sitting here for 5 minutes trying to figure out 2 specific numbers that multiply to give me 1260. So if you can't think of anything immediately off the top of your head, instead of looking for 2 factors that I multiply together, let's just look for a single factor that I know divides into 1260. 1260 is an even number. I know it divides by 2. So now you say, okay, now I can do this. Let me do 1260 divided by 2 in my head. You do it. That still feels kind of big, or I just want to punch it in the calculator, just quickly knock it out. So you do 1260 divided by 2 in the calculator, and we get 630. So I've broken down 1260 to 2 times 630. Same thing with 630. It's still even. I can divide it by 2, get 315. All right, so now 315. Problem with 315 is it's not even. Okay. So you know, if you're kind of going this route that I'm talking about now, if you don't know immediately two things that multiply to get a number, you know, if it's not even is the one we all know. If it's even, it divides by 2. If it's not even, you're gonna have to remember some of those factoring rules. Okay, stuff y'all learned in elementary school. Something has a factor of 3 if all the digits in the number add up to a multiple of 3. So 3 would work here in this instance. 3 plus 1 is 4. 4 plus 5 is 9. 9 is a multiple of 3. That's the rule for 3. 6, if 2 and 3 are factors of a number, then 6 is a factor of a number as well. 9 is the same as 3, but they all have to add up to 9. Add up to a multiple of 9, not a multiple of 3. But probably the second and third easiest ones behind 2 are if the number ends in 0 or if the number ends in 5. If it ends in 0, I know it divides by 10. Like I said earlier, 126 times 10. 63 could have been 63 times 10. Also, if a number ends in 5, or if it ends in 0, I know it would divide by 5 as well. If it ends in 5, I know it would divide by 5. So that's the rule for 5. If it ends in 5 or 0, it divides by 5. Again, think about it for counting. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. They all end in 5 or 0. So I know this divides by 5. So we're going to use 5. Again, do it in your calculator. 315 divided by 5 is 63. Now 63 hopefully is one that we know. 7 times 9. Then 9 goes to 3 and 3. So I've completely broken this down. Again, if you got the room, I'm telling y'all, don't do this if you're trying to cram it in a tiny space, or if you have sloppy handwriting. It's just going to make things messy. But if you did it in a decent amount of space, you can clearly see what you did. Cross out everything. There's the bell. So I'll just have to finish this example real quick. Cross out everything that you broke down. So now you're left with 2, 2, 5, 7, 3, 3. My pair of 2s go together. My pair of 3s go together. I have a single 5 and a single 7. So for my pair of 2s, let me draw the square root sign. My pair of 2s goes out of the house. My pair of 3s goes out of the house. My single 5 goes in the house. My single 7 goes in the house. So a bigger number, you can still do the factor tree. If you can't think of 2 numbers to multiply to get it, just think of one factor and divide it and work your way down. Now this is showing if you have multiple numbers either inside or outside. Could be 2 inside, 2 outside. It could be 5 outside, just 1 inside. It could be 1 outside, 6 inside. If you have multiple numbers either outside or inside, or even if it's both, you just multiply whatever it is together. So multiply what's outside together, 2 times 3. If there happened to be another 3 here, 3 times 2 times 3, which of course is not the case. Five times 7 multiplies. 2 times 3 is 6. 5 times 7 is 35. And you still stick the plus minus on. So that covered almost everything else. The really only thing it didn't, and I'm trying to go because I see somebody at the door. If you have multiple pairs of 2s, multiple pairs of 3s, whatever, you still got to put that many out here. So if I drew the 3s out here, right? If I had another pair of 3s over here somehow, so I had a second pair of 3s, I would put a second 3 outside here. Okay, you should never have multiple 5s, multiple 7s, whatever, underneath the square root. So those are the examples we did in class. Again, if I get this posted, y'all need a few more, I'll record another video with a few more examples and get those posted into your assignment as well. But hopefully that should be enough to kind of get you going on this simplifying radicals assignment. Let's see if I can back out now. I don't know if it'll let me back out the whiteboard. Let me see here. I don't want to export it. I don't know if I can get rid of the whiteboard. Well, I don't know. I'll just get rid of the whiteboard. But y'all can see my little talking head in the corner. So again, I'm going to wrap up the video now. If y'all got any questions, let me know in class. Other than that, oh, I see closed whiteboard up there. There it is. Anyway, y'all got any questions? Let me know in class. See y'all next time.